Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT/IC Department. Welcome to the video tutorial series of the Internet of Things. And this today's session, we are going to discuss about addressing and the identification protocol. Right? So we have seen the very famous addressing and the identification protocol. That is an IPv4 in our previous session. Right? So we have seen every aspect about IPv4, how it is classified into the class A, B, C, D, E, and how its frame format is there, right? After that, in today's session, we are going to discuss about an IPv6, right? Why we need an IPv6 where the IPv4 already was in the market, right? So what is an advantage of an IPv6? What are the feature of an IPv6? And what are the frame format for IPv6, right? We are going to discuss that. After that, the Uniform Resource Identifier or URI, and in that there are two types: the Uniform Resource Locator and the URN is there, right? So we will going to discuss that too in this particular session, right? So let's begin with the IPv4 that is already in the market, right? So by that we can identify the host and the network in the network, right? So why there is a need of an IPv6, right? So with the increasing of the number of the devices, right? So right now, what is the scenario right now, right? So currently the number of the devices which are connected with the internet is increasing day by day, right? It is drastically increasing, right? So as the number of the device grows connected to the internet, it is obvious that we need a more number of the IP address to assign that to all of the objects, right? So whenever we have a large number of the devices, right? So we need to assign that devices the IP addresses to, right? So for that particular kind of requirement, we required a large number of the IP addresses, right? So that's why, and that is not, the IPv4 is not capable for that, right? So that's why the IPv4, the Internet Protocol version 6 is evolved, right? In the IPv4, right? So you can see that the IPv4 is having a 32-bit of the IP addresses, right? So the IPv4, the IP addressing using a 32-bit of the IP addresses, and which can generate only 2:32-bit of the IP addresses, right? So theoretically, that value is just above the 4 billion, right? So in fact, the actual available IP addresses in the IPv4 is even less than that particular theoretical value, right? The actual IP address that we can assign in the IPv4 is around 3.7 billions, right? So the IP address, the Internet Protocol version 6, right? So the IPv4 is having an 32-bit of the IP addresses, where in the IPv6 it is having an 128-bit of the IP addresses, right? So here in the IPv4 it is having 32-bit of IP addresses, so it is having an 2:32-bit of the IP addresses. Likewise, the IPv6 is having an 128-bit of the IP addresses, right? So it is having a 2:128 bits of the 2:128 bit of an IP address, right? So that value is very large. That if that above value is very large, that if we assign a unique IP address to every item in the world, then also it will be have reserved IP addresses, right? So you can see that how the ocean of the IP address which is provided by the IPv6, right? So that's why that we need an IPv6 over an IPv4, right? So let's see some of the salient feature which is provided by an IPv6, right? So let's begin with that, right? So IPv4 is having a limitation, some kind of thing, right? And IPv6 is having some of the salient feature above that, right? So first one is an efficient algorithm for that, right? So IPv6 having a better and efficient routing rather than a IPv4, right? After that, the additional flow label is added in the header of the IPv6, right? By that we can get a better quality of the services, right? So in the addition of the flow label, in the additional flow label is added in the header of the IPv6 for improvement in the quality of the services, right? The IPv6 as a new application like IP telephony, video conference, audio conference, video calling, audio calling, the interactive gaming and all that things, with ensure that quality of the services, right? So that is a salient feature for IPv6, right? The plug and play availability with an improved in the plug and play ability have been improved in an IPv6. IPv6 has eliminated the need of network address translation due to the huge availability of the net IP addresses, right? So that are the salient feature of an IPv6, right? So let's see what is the header format for an IPv6, right? IPv6 header format has less field than IPv4 header format, right? But the IPv6 header is in 40 bytes, which is twice than an IPv4 headers, right? The figure is shown that it is the figure is showing that IPv6 header format, right? So in the IPv6 header format, there is an IP version number, traffic class, flow label, payload length, new header, hoop limit, the source and the destination address, right? So IP version number is having an 4 bytes, and traffic addresses is having an 8, flow label having an 20, payload having an 16. Next header is having an 8 and hoop limit is having an 8 byte respectively, right? After that, the source and the destination address is having an 128 bytes, right? So let's see each and every term one by one, right? First one is an IP version, right? It is a 4-bit field to represent an IP version being used, right? So which is the version of an IP we can assign with that particular 4-bit, right? Which is assigned in an IP version. After that, the traffic class, right? It is an 8-bit field to identify the different classes or priority of an IPv6 packets, right? So with the help of that, we can track a traffic class, right? After that, it is replace the type of services in the IPv4, right? The traffic classes replaces the type of service in the IPv4, right? Upper and the particular traffic class, the 8 bits are divided into two parts, first 6 and the last 2, right? Upper 6 bits are used to type of the service and lower 2 bits are used for explicit congestion notification, right? So that's how the traffic class, the 8-bit traffic class is divided into the two parts. The first 6 is used for the traffic type of the services, and the rest 2 is used for explicit congestion notification, right? After that, the flow label is there, right? And it is a 20-bit field used to identify the sequence of the packet, right? The sequencing of the packet you can handle with the help of that particular flow label, right? It is also useful for the prioritizing the delivery of the packet and providing them real-time services, right? As we have observed that IPv6 is providing video, audio calling and all that things, right? So at that time we need a real-time services, right? So with the help of that particular flow label, we can get that particular services too. The higher priority packets can be delivered ahead of the lower priority packets. That is an obvious thing, right? After that, there is about an IP version which is having an 4 bits. After that, traffic class and the flow labels that we have seen, right? After that, the payload length, right? So what do you mean by the payload length and why does it is used, right? As it is a self-explanatory, right? It is a 16-bit field which identifies the length of the payload of IPv6, right? So that is a self-explanatory. After that, the next header, right, which is having a 6-bit, right? It is a 6-bit field which is similar to protocol field in IPv4 headers, right? It represents the type of the extension header that follows the primary IPv4 headers, right? After that, the hoop limit is there. It is an 8-bit field equivalent to time to live in IPv4 headers, right? The value is decremented by 1 every time when it is forwarded by the one host, right? So with the hoop limit, we can limit the hoop, how many hoop you can transfer the data, right? The value is decremented by 1 by every time whenever we forward that particular field from one host to another host, right? And when the host limit is reached to the 0, the packet is discarded, right? So there is a functionality of an host limit. After that, the two field is there, right? Source address and the destination address, right? As it name suggests, what do you mean by the source address and what do you mean by the destination address, right? So yes, you are right. right? The source address represents the 128 bit of IP addresses of the source or the sender, and the destination addresses is representing the 128 bit IP addresses of destination of the receiver, right? You can say that the source or the sender as in source and destination or the receiver as in destination, right? So that's about a file format, the IPv6 header format for the same, right? And we have seen each of the field and its bit sequence and what is its functionality in brief. So that's about an IPv6, right? And why we have chosen that IPv6 over an IPv6, and why we have evolved from IPv6 v4 to v6, that we have seen in this particular session, right? After that, let's move forward about another protocol, that is an uniform resource identifier, URI, right? So uniform resource identifier is used to identify the resources with the help of sequence of the characters, right? The URI protocol was developed by IETF, right? And the URL can be URL or the URN, right? So the simple for the URL and the URN can be as followed, right? The universal resource identifier is classified into the two types, right? First one is the URL, the universal resource locator, or the universal resource name, right? The simple for the URL and the URL can be as followed, that we have seen. The URN, we mostly provide the information for unique name without locating or the retrieving the resource information, right? When you don't require to locating and the retrieving this resource information, at that time you can use an URN, right? But when you need to locate and retrieve the resource information, at that time you need to use an URL, right? URL provides locating and then retrieving the information on the internet, right? So that is the basic difference between the URL and the URL, right? So whenever you are locating and then retrieving the information on the internet, at that time you need to use URL, and whenever you don't need to retrieve and locating the resource information, then you can switch over to the URL, right, which is stand for universal resource name, right? After that, the universal resource locator, right? So let's see in brief. The universal resource locator contains the information of how to fetch a resource information from its location, right? With the help of the URL, we can fetch the resource information, right? So with the help of that, it contains the information about how to fetch the resource information from its location. URL always begin with the protocol like HTTP or the HTTPS, right? And the URL is used when the client requests the server for specific services, right? So when the client is requesting the server for specific services, the URL is used, right? The simple URL and its field is express field, right? HTTP www.lgit.edu.in/study material/IoT/syllabus.html, right? The first one is an HTTP, right? That is defining an HTTP protocol. After that, the World Wide Web that we have assigned. After that, we need to identify this domain, right? Particular domain name we need to identify or specify, right? The first one is an HTTP protocol. After that, World Wide Web, and after that, the domain name, right? After reaching to the domain name, which path we have to follow, that we need to describe there, right? So study material IoT is the path for that, right? So with the help of that, we can track and path from that particular domain name, right? After following that particular path, we are arriving to the particular file destination, right? By that, we can access that particular file, the syllabus.html file we can retrieve from that thing, right? With the help of the HTTP protocol, which kind of protocol we are using, that is defined there, right? After that, we need to reach to that particular domain name with the help of the World Wide Web, right? After reaching to the particular domain name, we need to follow that particular path to access that particular file name, right? So that all the things is defined in that particular URL, right? So that's about an URL, right? In this particular session, we have seen an IPv6, right? Why we need an IPv6 over an IPv4 and all the basic fundamental things, all its header formats and all that things we have seen in this today's session. After that, we are switching forward about an URL, right? And in the URI, there are the two types, URN and the URL. Right? And what is the basic difference about URL and the URN? Where does you can use URL and where does you can use URN? That we have discussed in brief, right? So that's all about today's session. Thank you for the watching.